Hi all, my name is Grant, and I sometimes go by Dark Yolks on the internet, and I recently found myself with a bit of free time on my hands. Now this could mean various things for different people, but for myself, this meant only one thing, and that is that it was time to reignite my Hack the Box Lab subscription and learn something new. Now I've been studying heavily for the PNPT from TCM Security. This is, of course, a pen testing certification, so a lot of offensive security tools and methodologies have been fresh on my mind. So when I resubscribed to Hack the Box, I actually wanted to pivot a little bit and go back to my first love of digital forensics and blue team work. So I was initially drawn to the Sherlocks here, but these are a little bit bigger labs, a little bit more thorough. The name Sherlock definitely suggests there's going to be a lot of steps to the investigation. You're going to be following tracks. You're going to be reversing malware. There's going to be a lot going on. So I am going to get to those for sure. But since I did want to go reinforce previously learned topics and knowledge, and then also learn something new and build on that previous knowledge, I went to the tracks section first. And I really like the tracks section because these are essentially going to be a compilation of labs put together under a certain topic or theme, and they're going to help set you up for the track title for the subject that it's in. So I immediately was drawn to the Intro to Blue Team Lab. When you click on this here, you'll see 9 labs pop up, and they're all ranked as easy difficulty. But I think these are all core fundamental SOC Analyst labs that are essential to digital forensics and reinforcing that knowledge. So there are plenty of thorough walkthroughs for all of these labs that show various ways on how to capture the flag. So instead of adding to that mix, I'm going to go through each of these boxes. As you can see, I've already completed them. I took thorough notes as I was running through them. So I'm going to just talk about them a little bit and mention one thing that was new from my perspective that I learned while running through these boxes. So we're going to start with the first box here, Chase. I believe all these boxes are organized alphabetically, but from my perspective, it kind of seemed like they were ordered by difficulty too, because we'll see later that the very last lab in this track is reverse engineering some malware. And in my opinion, that is a little bit harder than something like forensics where you're looking through logs. And that's actually what this first box is. Now, this is going to be a pretty standard PCAP analysis, so packet capture log analysis that will be done through Wireshark. So a brief overview of this box is you'll be sifting through traffic looking for something abnormal, something that looks kind of strange or off, whether it be a shell, reverse shell, maybe some tools you might recognize. And then once you find that activity that looks a little bit strange, you're going to want to follow those packet streams and see ultimately where they lead. And as you go down that path, you'll find an encoded file that will ultimately be decoded with CyberChef. Now, CyberChef is going to be in use in pretty much every single one of these boxes. I probably won't mention it every time, but just note that whenever you're doing anything digital forensics based and there's encoding, CyberChef is going to be your best friend. So I can't say I learned anything super new with this box. However, I did enjoy running through it, and like I said, it is an essential core lab that is perfect for someone interested in SOC analysis or looking to refresh their knowledge they already have. So, big fan of Chase. I give this one a solid 7 out of 10. Up next, we have the box Event Horizon. In this box, the scenario you're given is a CEO's computer is compromised in a phishing attack, and the attackers cleared out all PowerShell logs. Can you help us? So we need to go look and find what the attacker was executing in PowerShell, even though they removed the logs. So we are given Windows event logs or Windows XML event logs in EVTX format. So if we go to our Event Horizon folder here, we can kind of take a look at these. If we cd into logs and ls, you can see we're given a lot of different EVTX files from Windows event logs. So we need to figure out how to parse these out. And that brings us to a really awesome tool that was used to help parse out these logs. And that's going to be EVTX dump here. This tool does all of the heavy lifting for us. So at this point, we just need to use it to parse out and enumerate all of our information. So we can look at our Windows PowerShell logs here. Looking at those, you will find out, yes, the attacker did in fact clear those out successfully. Then you have to put on your digital forensics hat here, think about where else logs can exist. So once you kind of figure that out, you can start narrowing down which logs you want to look at. Spoiler, Windows Defender is going to be picking up on commands executed, so that might be a good place to look. And eventually, as you're sifting through these logs, the EVTX tool here, if I just type in this command that was previously ran, you can sift through specific locations. So Windows PowerShell, for example, Windows Defender has a few different logs here you can sift through. And essentially when you run this tool, it's going to parse out the binary and print it into a readable format. So you'll just need to specify the output file here. So I could run this again. And then if I go to cat results.txt, we can start looking through these. So this will print them all out, and then you just need to enumerate further. Look for things that look suspicious. We know we're looking for PowerShell, so we could even do cat our results and then pipe a grep in there for PowerShell, and that'll narrow down our logs a little bit more. But I'll leave all that fun stuff up to you all if you want to go figure out this box. So what did I learn from Event Horizon? It reminds you to think outside the box. Don't always assume that just because something's deleted that it wasn't picked up or logged somewhere else, especially with Windows, especially with PowerShell. So in this case, the PowerShell logs were deleted. Where else are you going to go to find PowerShell logs is kind of where you need to start thinking. And also, this lab is the beginning of a series of labs in this track where I'm reminded it may be easier just to sift through them in an isolated VM so you can look through them how Windows intended. With that said, though, that could be considered the easy route, and then I wouldn't have had the opportunity to really dive into this EVTX dump tool. And now I have this in the tool belt. I have this knowledge, so if I ever encounter these Windows XML event log files again, I know I can utilize this tool. So that's going to be kind of the theme that goes around with these boxes here is there's going to be multiple ways to figure them out. Spend the time, figure out those different ways, because that gives you a wider range of tools to use when you encounter it down the line in your career. So let's go back to our list here. And up next we have export. Export is all about working with Windows memory. So if I'm not mistaken, I believe you're given a Windows memory dump. Yep, looks like that's the case. And then you need to parse out that data and make sense of it. Now, anytime I'm working with Windows memory or memory dumps in general, the tool volatility comes to mind, which we'll get into in a minute. But before I spent a lot of time working with volatility, I was introduced to a new tool called binwalk. Now, binwalk is a tool that will parse out memory dump files and check for offsets in that memory. Now, I used it more so to confirm I was working with memory files, just to make sure I could see what I was working with, and that actually returned the offsets. So if I go into export here in LS, I could do binwalk and then use our memory dump file here. And then this will return the offsets for those files. So there's a lot to get into here. Binwalk is a tool I definitely need to look into more. That's kind of the summary and what I'm getting to with export. So after we've enumerated and confirmed what we were looking for with binwalk, I dove into volatility. So with volatility, you are eventually able to enumerate the suggested profiles to use with this memory. And with that information, you can begin enumerating further and ultimately narrow down specific applications or functions that were stored in memory. This lab was very fun. Anytime I get to work with memory, I'm a little bit intimidated, but I always find it very interesting, and it always makes sense on a very logical level. If you don't work with it every day, it can just take a little bit of time to get used to working with. Okay, moving on to our next lab in the track. Up next is Insider. So in this one, we take a look at a different layer. So we are given Firefox files that contain various things such as logins, extensions, storage. Essentially, when you do an export of a Firefox or a Chrome profile, it's going to contain all of that information. So we need to enumerate all of this and figure out what's going on. And this is actually another one of those scenarios where it might be a little bit easier to just load up the Firefox profile into a local Firefox instance, maybe even in an isolated VM just to be safe, and parse through the information that way. And that is definitely the case with this lab here. With that said, though, I did not take that approach, and I spent some time looking around, and I found another great tool. This video is kind of just turning into a showcase of tools, but nothing wrong with that. And that tool is Firefox Decrypt. So you can use this tool on specific Firefox profile files that contain encrypted credentials. So these will be things that are saved in memory, like when you enter your username and password on a website, and the browser you're using asks you to save the credentials. So to solve this box was fairly straightforward. All you would need to do is run the Firefox Decrypt tool on either of these profiles until you find the password for the user whose profile you have, and that will contain your flag. Up next on the list is a box called Logger. So in this scenario, we are told that a client is reporting a PC might have an infection, and that they've collected all evidence from the workstation and found suspicious USB traffic. Can you identify the compromised data? So if we go back to our Hack the Box folder here, we can go into Logger. And then I do have a keylogs.txt file in here, but this is the export that was ran later. But ultimately you are given a PCAP file that you will take into Wireshark and start analyzing some USB traffic. So when you're sifting through the USB logs in Wireshark, trying to get a lay of the land, you'll be looking at various devices connected through USB ports. Now, the name of this box is Logger, so that gives you a pretty big hint that you're looking for potentially a keylogger. So in my process, I narrowed down what the keyboard was. That revealed some HID data and the device address. From there, you're able to extrapolate on that and follow those streams to figure out what that USB device was doing. Now, something that was completely new to me that I hadn't used is a tool called T-Shark. So since T-Shark is the terminal command line version of Wireshark, the syntax is the same, but I'm still digging into it a lot. I have a lot more familiarity with the Wireshark GUI, of course. So this was the main point of focus for me, and something I'm going to go back to and learn more about. Utilizing the walkthrough, I was able to utilize a T-Shark command that outputs the HID data for our specific USB device address here, which is 16. So this will be our keyboard, and this will output all of the binary HID data to a text file, and then we can use another tool to actually parse this data. Now, the tool I used to actually parse the HID data was a really cool tool from CTF USB Keyboard Parser, and that is usbkeyboard.py, another Python script. This tool works incredibly well and worked first try, so that's always nice. And once you run it on your outputted binary file that you got with T-Shark, and then you're actually able to see every keystroke that was entered. So you'll just have to manually adjust based on the caps lock here to get your flag. But ultimately, this was a very, very fun lab, and I learned a lot about USB device addresses and how that binary data actually gets parsed out and how you're able to extract information from that. So this one is great for looking into hardware logs versus network logs, which is what you'll see more commonly when doing PCAP analysis. Moving on to the next box. Next up, we have Lure. So in Lure, you're given a scenario that the finance team received an important looking email containing an attached Word document. So you're given this Word document and you need to figure out if it's malicious, and if it is, what it is doing exactly. So I haven't mentioned it really yet, but anytime you're doing digital forensics like this and you're given files, it's recommended to run the commands file and strings on files. And a very simple way to explain these is it's going to return information about the file and look for strings in the file that may be relevant or unique. So with this .doc file we're given, we definitely want to utilize these tools to be able to extract any unique information about them. So I believe it's in the walkthrough. It may not be though, but there's also another tool called Olevba by OLE Tools, and maybe it's not even pronounced Olevba, but I like saying it that way, so we're going to stick with it. Now, Olevba is a script that parses out OLE files and OpenXML files, and these are going to be things such as Word or other Microsoft Office documents like .docs. So this is exactly what we're looking for here. So to give a very quick demo on this, I'm actually going to go to our files we have here and run Olevba on our urgent payment doc, and you'll just see how easy it is to run. Now we can see what this tool is doing here a little bit. So it's actually looking for macros in the .doc file, and it found one. So the attacker is utilizing an environment variable called user domain, which is going to return the name of the joined domain as a string. It will then compare that string to this megabank.local domain, and if the string matches, it's going to proceed. Now, if the user domain string here matches megabank.local, it is going to use this else statement here to execute a PowerShell shell. Now, there's a lot more to dig into with this tool and what exactly it's doing to parse out all of this information, but it's all really, really good stuff. So I recommend checking this out if you're interested in it. I know I have notes to go back and dig into this more. But we have what we need here. So this PowerShell command is what we're going to use to kind of backtrack and see what's being executed. Now I struggled with this bit here for a while, but ultimately this is going to be brought back into CyberChef and do some decoding on it. Now the UTF encoding is the part I had trouble decoding, but it is possible. I just clicked around for a while and was able to figure it out. While I was figuring it out, I actually had ChatGPT help me write a Python script that would decode this for me. And it did a pretty good job, actually. It just missed a few characters, but it still gave me enough where I could go back in myself and manually edit the flag and capture it that way. So ChatGPT was able to assist with the lure box. So on to the next box we have. It's going to be no place to hide. So no place to hide, the scenario is they found evidence of a password spray attack against the domain controller and identified a suspicious RDP session. They provide us with RDP logs and other files. Can you see what they were up to? So it seems like this password spray attack against the DC was successful, because they have RDP logs that kind of show the connection and what happened, is what it sounds like. Now, running file and strings on these, we'll find out later, bitmap files, doesn't actually return anything successful. So the only way we know these are actually RDP logs is going to be from the description of the lab here. That kind of doesn't leave us with a lot. So utilizing Google, we could search for something like an RDP cache parser and then look through the various tools they have. I landed on BMC tools here. So what this tool does, it processes the .bmc files and the .bim files found inside Windows user profiles, and that does appear to be what we have here. So we can run the bmc tools.py on our cache 000.bin file, and then we want to make sure we output this to a specific directory. So I had to go ahead and make a directory beforehand, and then this will output all of our bitmap files, which we'll see later are essentially images that you can look at, and then compile those. So BMC tools will actually compile all of these images into a file for us if we use the -B switch or the --bitmap switch. And this tool did not do a great job of compiling the image. It was very scattered. However, it was put together enough for me to actually figure out what's going on and be able to read the flag on the screen. So I actually haven't had to work with bitmap files or RDP files for that matter when it comes to forensics. So with this lab, I learned a lot about the way RDP bitmap cache files actually work and how they can be parsed out to extract information. Now for the second to last box in the list. This one is going to be called persistence. So with persistence, it's important to know how attackers and pen testers will use registry files to maintain persistence on a system. So when a hacker or pen tester has access to a computer and that computer gets turned off and then turned back on again in the morning, how is the attacker going to have access to that system when it comes back online? Now, one way is to edit registry files. So doing some research into this, you can find information about certain paths that are commonly edited to maintain persistence. But there is a way to sift through Windows registry files on Kali. One built-in tool is something called regshell. And you can use a shell-like interface to look through the files and figure out where you need to go. So now that we know certain paths that attackers use to maintain persistence in the registry, we can start navigating through the registry to look at those paths. After looking through those paths, there's one Windows update that looks kind of suspicious, and that's what stands out the most. So once you have this strange looking executable and you're familiar with things like base64 encoding, you'll know that that's kind of what this looks like. So you can take this into CyberChef once again to get the final flag. Knowing how to maintain persistence and how to identify how persistence is maintained is crucial to being a successful SOC analyst or penetration tester. So this persistence lab is a simplified version of how this is done in a real-world scenario, and it is a great introduction to Windows persistence from the forensics perspective. This one might be my favorite in the entire track, actually. Now on to the final lab in the Intro to Blue Team track. We have Ransom. So we actually get to do some reverse engineering on some ransomware. Now this is totally out of my wheelhouse. This is something that feels a little bit intimidating to me, but it's also that much more exciting because I don't get to work with it that often. So in the Ransom lab, they have received an email from Microsoft support recommending a critical patch. It's a phishing attack, and the system admin downloads the attachment, and now all of the data is encrypted. Can you help us decrypt the files? So not only do we get to reverse engineer the ransomware and find out how it encrypted everything, we actually get to decrypt it as well. If only that were the case in real world scenarios. So it's very fitting that this is the last box in the intro lab because it could be perceived as the most complicated just because it's a little bit more technical and logical. It, of course, is reverse engineering. So it's going to be slightly more advanced in the digital forensics domain for most people, but this is very approachable. So I fired up Ghidra and then took a closer look at the Windows update file. First looking at the main code block here. So main here appears to be a compiler provided function that just runs global constructors. So if no user arguments are provided, then the file name will default to the directory of users on the C drive. So in the nature of this video, I'm not going to get into the details too much, but the main two functions in this executable are going to be encrypt and encrypt file, because that's how we're going to be able to decrypt these files. And when we take a closer look at these, we will discover the keys that were used to encrypt all of the files, and utilizing intuition and tools like strings on Kali. Then once we have an idea of what that key is, we can take it back into CyberChef and supply the key, subtracting those values that we saw earlier in the encrypt file function. We can save it again and then view all of that decrypted information, which is of course going to contain our flag. So that is all 9 labs in the Intro to Blue Team HackTheBox track. So all in all, I really enjoyed these labs. I think each of them contain fundamentals for being a SOC analyst or pursuing Blue Team certifications. And even from an offensive security perspective, these labs provide a lot of insight into what the other side looks like and is a good reminder for things to look out for when it comes to covering tracks or maintaining persistence and kind of what paper trails you're going to be leaving as a pen tester. I hope you enjoyed this video. I plan on making more soon, both technical and more opinionated pieces on things that are going on in cybersecurity. So if you enjoyed, consider subscribing and maybe leaving a like or sharing the video. Thanks all.